All right, Andre is going to talk to us about LTE testbed.
Well, yeah, kind of. Okay, so yeah, no, yeah, it's right. Thanks, Phil. So I'm Andre. I'm with Software Radio Systems, and we do srsLTE. Who of you guys knows about srsLTE or has heard about it? Who has actually used it? That's not too bad. Cool. So hopefully we learn a little bit more about this today. So we are a relatively small company, headquartered in Cork, Ireland, with offices in Dublin as well. But most of our development takes place in Barcelona, Spain. And we are 9 people, and we are growing. As far as FOSDEM history, so it's been long actually since we started business really. So the first talk at FOSDEM about our software has been given by Ismail, back then liblTE, as an open source file library for doing signal analysis or LTE signal analysis. Then 2015 there has been a talk given by Paul about an overview talk about available LTE, SDR software platforms. And there has been another talk 3 years ago by Ismail already looking at srsUE, so the first UE implementation utilizing the base file library. And now 2017 and 2018, what have we done? Did we do anything at all, or did we just relax on the beach in Barcelona? No, we worked, and 2019 we're here again. So the srsLTE ecosystem, as you might know, so srsLTE is first of all a library, a file library, which we use for a variety of applications, and it basically implements the PHY as well as, and that's why it's a core LTE library really, as well as common blocks that we share in upper layers as well. So from PHY, MAC, RC, PTCP, RC, you all have helper functions that are shared among. But then on top of the core library, such as srsU, as I said, src node B, which is fully functional LTE node B, and our most recent offspring srsEPC, which is a lightweight core network implementation. And there's a bunch of other commercial products that also build upon srsLTE or the core library. So as a company, we're doing public projects as well as commercial projects. Why I'm bringing this project here specifically is because this has guided our development roadmap for the past 2 years actually. That's a project called Open First, funded by NIST in the US. And they funded us, or still fund us, to build a fully end-to-end open source LTE network testbed with specific focus on public safety. So that's because they're most interested in. So we open sourced functions are of particular interest to the public safety community, such as InBMS and D2D and other things. And we will have a look at this in a minute. So this slide should just give you a little bit of an overview about the releases of our software. So the left-hand side of the slide is basically the old version scheme, which we started with just normal 0.1 and so major minor releases until version 2, which is only 1.5 years old, and we then switched to like that year-month scheme that you probably know from Ubuntu, for instance. And with that, we also introduced. So in general, we're trying to release our software quarterly, so get out a new release every 3 months, and we are following kind of a TikTok model there, where we in one release we're trying to bring new features into the software, and in the second we're starting in a smaller feature change list. First of all, trying to stabilize the software, but also to take the opportunity to refactor lots of stuff. So that's something that you usually don't see and people don't really appreciate, but we have to do that constantly in order to be able to get all the features into the software and to extend it at the speed that we are doing that right now. And yeah, besides the 17.12 release, I think we were like almost a month behind. So that was released in January or start of February 2018. I think the releases were all kind of in a week window after the version or what the version number suggests. And just recently we released 18.12, so that's our brand new release there in January. So I've collected what I call the important srsLTE releases because they include quite some interesting features. Just to give you an overview. So in srsLTE 2.0, we added or we made the srsENODE public. And a big change for those of you who knew the project from before, we merged srsUE, which used to be a single repo, into the srsLTE code. So now, from that point onwards, there was no longer the need for having a specific srsLTE library, which back then only included the FI and the common code, and to have the matching UE or vice versa. So that went all into on a single repository, like the eNodeB as well. Then in 17.09, we added MIMO support for the FI layer and also the UE. So that gives us transitional 3 and 4 for those of you who know that. So you can actually do with a 20 megahertz LTE cell, you can do 150 megabits downlink in software running on your mid-range computer, I'd say. Then we added eBMS, that's a broadcast services for LTE. So you could have a base station transmitting, for instance, a video stream and multiple UEs receiving that rather than each UE receiving the individual stream. I don't know if that is used in the public at all, but it's an LTE feature that was brought into release 10. Then with release 17.12, we added MIMO to the eNodeB, so you can also, like previously, you could receive from another eNodeB the downlink signal. Now you can also generate it with srsENODE and serve commercial UEs with that. We added our first release of srsEPC, and from that moment on, you could really build an entire LTE end-to-end from handset, base station, core network, just using open source software. We also added handover and user plane encryption to the UE, so you can roam between cells. And then in 18.06, after, if you remember, after adding eBMS in the FI, we extended, and the UE, we extended it to the eNodeB and also the EPC. So all those changes require, like the eBMS, for instance, require quite an amount of work in the core network, not only the radio access network. So, and those features generally just go to the UE first, the first FI, then the UE, and then the core network as well. We had something that we call hard SIM support, where you can use a commercial SIM card reader, plug your SIM card in, and then connect to a commercial, do the authentication with a real SIM card as well. And then, last but not least, so our latest version, 18.12, in which we introduced the biggest change so far in terms of number of code being added and removed from the code base is a new ASN1 library for packing and unpacking RC messages. So that's a big dilemma in all the open source radio projects. So there's you need to, in order to pack and unpack these messages, you need to understand ASN1, and we've previously relied on code from OpenLTE, and but the limitation there was simply that this is stuck to, the development got stuck at release 8, and we partially added higher releases, but it's very cumbersome to write that code manually, especially when you go upwards. And so release 15 RC, that's thousands of messages, and you don't really want to write that manually. So we developed a code generator for this, and we're now future-proof of that, so we can actually generate our own packing and unpacking code there. As well, we added encryption to srsEPC and IPv6 support for the UE as well. So what's our roadmap for 2019? So as I said, so there will be 4 releases this year as well. A little bit, I don't want to make too high promises, but definitely what's going into the release is closed-loop power control in the UE. Then depending on how the refactoring of our PHY goes, like TDD support. So that's the mode, for those of you who don't know, like in China, for instance, or also in the US, the carriers usually use TDD, and in Europe it's FDD. So where uplink and downlink is on different frequencies in FDD, in TDD it's on the same frequency. And that's, for instance, a good example. But we really required an overhaul of the PHY library, and that's currently on a merge. Then we add carrier aggregation to the UE, so we'll be able to run up to 5 carriers with one UE. And there will be user and developer documentation, a long-awaited thing. So later in 2019, I expect carrier aggregation in the eNote B, and also site-link for the PHY, and probably, as I said, it's going to be integrated in the UE first. But it's we cannot commit on a particular release for those features, I'd say. Binary packaging, so that's something that Marco said. So you're still not able to install GNU Radio, and that's something that we also had problems with. So every now and then people came and said that it's too cumbersome to install the binary or to install dependencies and build the software, and that's true. And that's what we added in 1806 Ubuntu packaging. So we maintain a PPA ourselves, and since then we basically push releases there, no snapshots. But with that you can install it pretty quickly. And then we've learned that there's also other people maintaining packages for SUSE or OpenSUSE. I don't know what's the difference in the packaging there. Those are maintained by Martin Hauke. And there's Debian packages, which are maintained by Ruben. And they are going into Debian SID, so unstable, and they're available. And both have actually, no, the Debians are not updated to 1812, but the SUSE packages are already at 1812. And perhaps there are also other distributions that have packages that we don't know. But yeah. Supported live hardware. So we have support for ATIS research equipment. So basically the B200 series, the X series. We still get support questions for the N210. We don't have a resampler, so we don't support the N210. We support natively the Blade RF, the old and the new one, and Epic Solutions hardware. And through SOAPy, those that we have tested is the RTL SDR for receiving, Lime, and also libIO, so on so analog devices on embedded platforms. And soon we will also have a radio driver that's actually not a hardware driver, but something called that we call no RF driver. So it's a 0MQ based radio driver. So what's this all about? So first of all, most of our testing and development obviously runs with RF hardware. But there's advantages to not using hardware during development, also debugging and continuous integration. So something that we really want to do is to run the full software, but turn off the hardware. Run it with PHY, but not do any hardware, and have those ideal, like as Derek said, those ideal signals there really. For instance, to be able to use tools like wall grind or address sanitizer or GDB to really debug things without needing to, to get samples to the user or receive them. To run the code faster, so to simulate, I don't know, an hour of network traffic in half an hour. To run it slower and also to pause code, as well as to model radio channels, for instance. So have a set of Bs, a set of UEs, and have a channel matrix between all those Bs and UEs. And also to plot signals and visualize them. But there are associated with that. So first of all, there's no eNote B or UE changes allowed, unless they make sense, obviously. But just for the purpose of putting that, we didn't want to introduce new changes there. And we only wanted to have the radio module as a like really as if it is a real radio, just working over IP, for instance, or a local transport. The problem here is that the way we typically use the RF hardware and the way we interface with the user through UHD is a little bit weird, because we're not always transmitting, we're not always receiving. We are, for instance, in the UE, we are receiving, so subframes is basically the time unit in LTE, so we're receiving not always one subframe and transmitting one, but the UE, for instance, receives 5 subframes and then another 5, and then eventually transmits 6 subframes later, a random access, for instance. So there's no continuous RxTX and no synchronous flow of IQ samples to and from the radio. And there's rate changes as well. So cell search, for instance, you do at a very low bandwidth, and then you increase your rate if you find the cell to be 10 megahertz wide or 20 megahertz wide. So that's something we needed to cope with. And there's something so there's still a few discussions going on as to where we put those functions, but in general, I think the idea is to have this no RF radio module, use srsMQ for transporting IQ samples, and use a request reply kind of model, have a blocking receive, and have the possibility to use different transports. Put a way of handling the timestamps that the UE generates and that the driver needs to understand and needs to interpret into this driver. And then we obviously need to have some buffering and padding of IQ samples, because of the way I just said, like a receiver expects input, but the UE does not always generate output. So we need to find a way how to deal with that there, and the resampling issue. And I think it's going to look like that. So there will be any UE, any eNote Bs, and M, so it doesn't need to be the same actually, number of UEs, eNote Bs, and kind of a broker that manages the interaction and shows to this side like as if the UE or the eNote B would actually be a synchronous RF device, receiving and transmitting always at the same with the same rate. So we stitched together a quick prototype, so it's actually quite useful to show that that it works. using srsLTE as a transmitter there, using your F7Q radio as a transmitter, and using PSCH UE, which is our lightweight signal, downlink signal sniffer, you could say, and using actually GNU Radio as a broker, because with that approach, you can straight away use the CRMQ request reply blocks in GNU Radio. From the E0B, adding them up, putting them through a fading model. There's a throttle block and a geophosphor plotter, and the same signal is also sent to the UE. So you actually have the channel model on GNU Radio, and that's how this looks like. So you have a slider there where you can introduce some noise there and make the signal slower or faster, so you can really observe every millisecond how the downlink is generated, how the noise is added, and how the UE sees that all piped through GNU Radio. And that's pretty cool, I think. Okay, so yeah, a few of you might wonder what's the 3 clicks thing there in the title of the talk. So when I put that title there, I thought that, okay, we have a PPA, so I should be able to doing a live demo there at FOSDEM in the software manager, type srsLTE, click it, and because it's installed as a service, it should actually be like 3 or 4 clicks. You should have the E0B there, but it's not going to work. I found out later. So PPA packages are not in the software center, and I don't know a way to install something that is in the PPA with just clicking mouse buttons. But I guess you appreciate that way as well. So it's adding the PPA srsLTE releases, doing update, install srsLTE. Then there's a command here. So if you want to run the EPC and you want to have internet on your phone, for instance, or the any other UE, you have to masquerade your device that gets access or provides internet access to the machine you're running on. So you have to call that script there and then run 2 commands on 2 different consoles, and that should get us internet. And we just give that a try here. I know there's people who hate live demos, but we just give it a try. Okay, so can you see the console? Yeah. So that's SRS E0B, and it's not installed. Okay, so there's nothing. And I also get your disk screen here. So that's. Can you see that phone? So that's a commercial like Android phone that we used here. So install E0B SRS EPC. So we install that there, okay. And then I do SRS EPC. So that's the core network. We need to launch that. I need sudo. And then there's sudo SRS E0B. Okay, so now I go to the phone. Can you see the phone? Yeah. I take that phone out of airplane mode, and I see the phone connecting, and I have this nice software radio systems LTE network there.
Are we going to prison?
No, I mean, we're not transmitting at high power, so it's all good. This will be okay. Yeah, don't get the. I don't know. Yeah. What?
Do you want to start getting ready?
Yeah. Okay. So guys, you see that we don't do the phone thing because I forgot to roam the. Well, anyway. So there's our 4G network. Okay, guys.
All right. We can take our speaker.
That's it.
This next talk, I'm worried about us all.
No, all good. Glad I made it on time.